Okay.
Have you ever played Cards Against Humanity?
Have you ever played what?
Cards Against Humanity.
Cards Against Humanity?
Yes.
No, but it sounds awesome.
I have a feeling you would enjoy this game to the fullest.
Is it like actually a tabletop card game, or is it a
It's like apples to apples.
apples? I've never heard of that either. I mean, it's not a computer game. It's like Magic the Gathering, actually physical cards.
Yes.
Okay. It's called what's it called again?
Cards Against Humanity.
Cards Against Humanity. Oh, that sounds amazing. What am I doing? Oh, laptop. Is it on? Is it on?
Yeah.
Yep. See, my neck's still a little tight. I don't have my yoga class till tonight. That sets me for the rest of the week. All right. Cards Against Humanity. So where do I get said cards?
My buddy ordered them offline. So.
This is like new?
Online. Sorry.
You ordered them offline from a guy named Guido. He runs the underground RPG card playing market. You can find him outside of iPick down at the Bayshore. So give me the quick premise of this game.
So what it is you have to have like a group of at least 4 people, or else it's kind of just like whose card is whose.
Okay.
But there's a judge and then there's the players, and the judge has a black card, and the black card says something like, "When I become a billionaire, I will erect a 50-foot statue to commemorate blank." And then the other people have 10 different white cards, and they get to choose whatever they want out of those white cards. And these white cards
Black cards, white cards. I get it. Okay.
the white cards are very grotesque. And so there's some of them that are like, I don't know if I should say them in class, but they're pretty ridiculous.
Okay. And those are like the fill in the blank for the statue?
Yeah.
Okay, so what's the gameplay like that?
You just go around until someone has like a limit of black cards. So whoever
You
has
try
the
to
most
win.
black cards at the end wins.
I wonder if I can get it off Amazon. Let's check. You can download the cards and cut them out? Who wants to be in charge of my card cutter outer?
Credit.
There's an online version of it too.
Is it really?
Mm-hmm.
So I don't have to buy the cards? I can play online?
Yeah.
Or is it not as good? Or do you know anything about this, or you
It's
just?
a lot more fun in person.
Oh, so you've played this?
Yes.
Cards Against Humanity.
That's the best card. I'm gonna go back to that.
Searching on our slow internet.
At least it works right now.
Does it? Oh, there's a third expansion?
Yeah.
Fourth expansion?
It is a ton.
Ooh, Cards Against Humanity, the bigger, blacker box. What's that? What's that? What's this all about?
Yeah.
Oh no, $36. This is just a bigger, blacker box that's made for holding Cards Against Humanity cards. Oh, I'm gonna have to research this during Bible study.
My buddy played it last night, and he was like, "All right, well, since I just lost my soul, I have to go to Bible study."
Man, that sounds amazing. But then again, I'm not recommending this for anybody. I have problems. When did you get a laptop? All right. So remind me, if you can somebody get the front light, please, because Abe's gonna just end up doing it anyways. Oh, Abe, did you go to church this Sunday?
Yes.
Do they have that voter meeting thingy?
Yes.
Oh, I was supposed to go, but my wife was too sick that morning. I was cheering.
Maybe that's. I don't know.
Did you stay for that?
No.
You just bailed? Aren't you a member?
Not yet.
So you don't have any voting rights. You can have my voting rights if you'd like. I'll be your proxy voter from now on. Yeah, I think my wife was getting installed as some committee chair or something like that, but she was still, yeah, she was still sick. So, but she was planning on getting up. So I get up early and I do my breakfast and stuff like that. And then I came back, and we usually leave at 8:35, and it was like 8:07, and she's still in bed, and it takes her a minimum of 9 hours to get ready. Like, yes. Only time I get out of church is when my wife's sick, or there's lots of music and she excuses me. Otherwise, I have to go. So I mess around on my
Christmas
iPad.
program is not your favorite?
Now with my autism, I have some issues with music.
Children?
I don't like kids either, right? But yeah, music specifically, I'm basically in a pretty rotten mood the rest of the day. It
So the
does.
two together.
Music does not sit well with me. It's messed up. Yeah, if any of you have ever been in my car, when the car first turns on, you hear my audiobooks kick in. I don't listen to music at all. It just puts me in a terrible mood. I don't know. Like I said, I have problems. Okay, so remind me, arrays versus linked lists. When will we use each?
Use an array if you know how big it is in advance and you and it's fast.
Okay, so if speed is of concern, you're definitely going to think towards arrays, regardless of whether you know the size of it. If speed is really a concern, then you're going to think towards arrays. But more importantly, if you know how big the data set is, an array makes a lot of sense, unless what? What would be the one reason to go away from arrays if you knew how big the data set was? Or what would be a reason to go away from arrays even if you knew how big the data set was? Go ahead. If memory is a concern. Maybe your data set is huge, right? It's like, yeah, I know we're going to have 7.5 billion records, but that's 7.5 billion records, and I have 1 gigabyte of memory, and I'm running Windows Vista. That was always kind of a funny thing at the Walmart computers. Does Walmart still even sell computers? They do. So the Walmart computers, they were when XP first came out. I think they were, you had these computers that were running XP, totally shouldn't be running XP. A lot like the netbooks. So when the netbooks first came out, the big reason that netbooks failed, really in general, was that they were selling small, underpowered laptops running full desktop software that was too beefy for the netbooks. So the early netbooks were all running like Windows Vista or later Windows 7. And you saw the later ones, they switched to Windows XP, right? So you could pretty much do everything on Windows XP as you can do on Windows 7, not the end of the world, but it had far lower system requirements. So Windows XP ran fine on a netbook. Windows 7, not so much. Plus you got 0 battery life. But that's kind of why tablets maybe took off, is that small, underpowered laptops never really made a whole lot of sense. But what I was getting at is Walmart, when Windows XP first came out, was selling these very, very underpowered, not enough memory computers with XP preloaded on them when the machine didn't even meet the minimum system requirements. And I don't know, it was all over the news and stuff like that Walmart was pushing these things. So then that's when Walmart switched to those same machines with Linux on them. It's interesting. Okay, so arrays, when we know how big the data set is and we have a need for speed, or memories, or avoid arrays if memories are concerned, if for any reason, right? Linked lists, very, 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 very memory efficient, but not so fast. Okay? So, last class, at the end, we started talking about nodes. So, a node is one of the chains, is one of the links in a linked list. So, nodes are linked to other nodes. So, every node holds a value, just like a bucket of an array holds a value. And then every node also knows about its next node. All right, so let's go from here and let's go write the equivalent class for a node. Looks like we maybe already did it. Is this what we were doing last class? Okay. So we wrote class node has we decide we're going to hold integers, so private int payload, private node next node, so this guy knows who comes next in the chain. When we first create a node, here's the constructor, we set the payload to whatever value was passed into the constructor, and then we initialize next node to nothing. It should be nothing anyways, but better to be explicit. Nodes know how to display themselves by just displaying the payload. And then we were messing around with the toString method and stuff like that last time as well, right? Where did the toString method come from? I'll bring up driver. So we created a couple of nodes, payload 5 and 7. First line we printed out n.toString, second line we just printed out n2, and we saw that both of them displayed whatever the toString method shows, which right now is whatever my parent's toString method returns, which is creepy memory address, followed by an arrow, followed by the payload. And we should see 2 memory address looking thingies with values after them. So, in this situation here, system.out.println n2, we saw that println is actually calling the toString method, correct? Well, who is our parent? If I'm node, who is my parent? Object. So we wrote that in there even though it's not necessary. So if I take extends object out, we'll see we run this, it still has the exact same output. Make sense? So that's proof that this guy is not actually required. All right. And that's the hierarchy of objects. So right now, this is a node. Nodes hold a value, know about their next node, but we're never actually using next node. So rather than our display method, we're probably just going to return, well, actually, we'll keep the weird looking memory address followed by value. That'll add to the allure of linked lists, so we'll see that the memory addresses aren't necessarily linear. Okay, so this is what our node's going to look like right now. Now we're going to create a class called linked list. Well, what is a linked list? Well, linked list is going to have a node that is the head of the list. So the beginning of the list. Constructor takes no parameters and initializes an empty list. And then for our starting point for our linked list, we're going to have a method. Here we'll say add method that takes a payload and creates a node and adds it to the end of the list. So that's what our basic linked list will do initially. Okay, so this will allow us to create an arbitrarily large linked list where we can only add things onto the end. Okay? So let's go ahead and create our linked list class. And you'll see we're going to take the exact same steps we took for node last time. So I'll create a brand new class. We'll call this guy linked list. Oh, and as a reminder, I shouldn't have to keep saying it, but when you do your homework assignments, you are not allowed to use the built-in linked list class in Java. You have to write your own. Okay? Because I haven't officially shown you that class yet, although a couple of you have seen it from a different class. Okay. So we have our linked list. Linked lists are going to keep track of a private variable called head, so they know where the beginning of the list is. We're going to have a constructor that takes no parameters and initializes the list to nothing. And I'm going to go ahead and I'm going to add a display method as well, just because We like that. So public void display. Actually, yeah, we'll have display method. I was going to do toString, but no sense. Public void display. What does this method do? It'll display the list. So right now we only know how to create an empty list. So I'll say if head is equal to null. That is, if we have nothing in the list, we'll print out empty list. Make sense? And that's all we know how to build at this point. So no sense adding an else there because we don't know how to check anymore. Okay. So that's our bare bones linked list. We're going to be adding an add method here shortly, but for right now, that's our bare bone linked list. So if we come out to driver, and I get rid of this stuff, and I create a brand new linked list, and then I say ll.display, it should say empty list. So we came in here, create a brand new linked list using this constructor. What did this guy do? It initialized our head variable of type node equal to null, nothing. And then when we called display, it asked, is head equal to null? Yes, it is. Print out empty list. That's all this guy does right now. Make sense? Okay. So now, we're going to have, now out of curiosity, somebody remind me, why did I make head a private variable? What advantages does that give me? Go ahead.
You don't want. You said you don't want to make it public unless you absolutely have to. Otherwise, someone can go in and change that variable that you might not want to change.
Okay. So rule of thumb is start off with all of your fields. This is a field, right? Start off with all your fields being private. Same thing for methods. Every single member of a class should be private to begin with. Eventually, you'll never write stuff as private to begin with. You'll kind of write it what it should be. But from our little rule of thumb perspective, start them off as private, then loosen the reins as necessary. So we're going to create this variable to be a private variable. When a variable is private, what does that say about that variable? Where can we access this variable since it's a private variable? Only inside of this specific class called linked list. What if we had made this protected? Where could we access it? It's from near the end of the semester last semester. We have three options: public, private, protected, right? Private means we can only access it inside the class name linked list, inside this class. Protected means we can access it inside this class or don't all speak at once. Unrelated question. How many of you have besides him, have a 60 beat in Flappy Birds? You have better than a 60? I thought it was going to be so good. What's yours?
70.
I hate you.
What
My
question?
brother?
Is it related to Flappy Birds?
Yeah.
Yeah.
How can you play that with your shakes?
Hey, shut up.
That's how he wins.
Actually, it's true. I use my right hand. I only have shakes in my left arm.
Oh.
Okay.
That's what makes it weird. That's why they can't figure it out. A lot of people, then they get tremors, they have them in both hands. Yeah, my right hand's fine. I'm left-handed, though. That makes it problematic. And I found that the best way to score high in that game is to not pay attention to the game.
Don't look at the score.
Well, definitely don't look at the score. Because as soon as you start getting close to your high score, you start flipping out. Right? But like I was sitting there watching golf all weekend on TV, just mindlessly, just playing this game, you get into this cadence. And then you go into like matrix mode where basically the game, you're not even looking at the top row. You're basically treating it like your little bird is just landing on the bottom things. That's what you're trying to do. And you just get into like savant mode every now and then, and then you would probably just keep going until you freak out because you're past your score. So I went from, I think, a 44 or 48 to a 60. And that the path between 48 and 60 was so stressful. I had to take a 45-minute break after that. So you have a 70, you have a 120, I have a 60. Anybody else have 60 beat?
My brother went from a 68 to 154. He was so mad.
Totals.
We've been competing back and forth. It started when we first downloaded the game in 11 was high, and then we went back and forth. One would get a few higher, the next one would get a few higher.
And how old's your brother?
27.
Okay. Okay, look, he's 5. They have nothing better to do with their time. What was my question? Protected.
Flappy Bird making 50,000 a day and then quitting.
What's up?
The guy made 50,000 a day and then he took it up.
I think maybe that wasn't true.
It's probably pretty close.
No, he probably was making decent money. I don't know about 50 grand, but regardless, Nintendo came out and said it wasn't them that complained. So
So he just got sick of the fame or something?
I'm sure there's more to the story than that. I don't think let's just assume he was making 50 grand a day. Let's say he was making 2 grand a day. You know, 2 grand a day off something you weren't touching. Cool. Chances are there was more to it than that.
Probably Apple.
Kids getting suicidal.
Yeah, there was a story about like a 3rd grader who killed his 2nd grade brother over a high score fight. Something like that. But who knows if that's true? You know, it's all sorts of rumors around the Flappy Bird saga. But all I know is I immortalized my 60. I was very proud of that.
They're selling phones. They're selling phones on eBay and now they have Flappy Bird.
Yeah, like 10 grand and stuff. These iPhone 5S's are selling with Flappy Birds installed. I doubt those are actually selling.
Yeah.
I'm sure that it's completely a bogus joke, and then they say, "Oh, I misbid on this."
Yeah.
All right, protected. Focus. All right. So a private variable is only accessible inside the class it is created in. A protected variable is accessible inside the class it was created, as well as children of that class. So it functions with the inheritance model. So if we were to create another class that extended linked list, we would have access to all protected members. Well, all public and protected members of linked list. Okay, but not private members. So if I kept this variable head as a private, if I were to create a subclass of linked list, he would not have access to that variable. Does that make sense? I'd have to loosen the reins a little bit in order to give him access to that variable. Okay, so that's the use of private versus protected. Public, and this kind of goes way back to when we were talking about our telephone. Remember when we were talking about there's 2 kinds of programming languages? Well, there was 3 kinds of programming languages: functional, procedural, and object-oriented. I said don't worry about functional. We had the procedural version of the telephone here on the table over here, where it was just a pile of wires that happened to work as a telephone, right? Remember that? Remember that day? Okay, so then the object-oriented version of it actually looked like a telephone, but only the public interfaces is the phrase I used. Only the public interfaces of that phone were actually exposed to us to be used. Okay, all the details, all the private and protected members of that phone were inside the plastic case. We couldn't touch it. Make sense? Okay, so we make things public that we want to be the public interfaces, things that are externally available to whoever's using our objects. So we needed to make our constructor public. Why? Well, we need to be able to build these guys. Okay? We're going to make our display public. Why? Because whoever's using our linked list might want to display it. He has got to be able to hit the display button to display it. That makes sense? So we make things public that we want to have accessible, let's just say everywhere. Okay. So that's our current version of linked lists. Now we're going to add a method called add. This method's going to return nothing. It's going to take in a payload, and it's going to add that payload to our linked list. Now, before I can add something to the linked list, I need to wrap it inside of a node, correct? So my linked list is a collection of nodes to give you a visual of a linked list. Just assume this is all over memory, okay? We'll change up our payloads. See, I've gotten a lot better at that, haven't I? I got this new snap thing. Epic. How do you play Flappy Bird with your shakes? In your defense, my wife asked the same question. Because I could barely feed myself with my shakes. I throw stuff off the fork all the time. And actually, these lids are a good idea because I am always spilling hot coffee on my hands when I'm walking down the hall, coming to this class after I steal coffee, post-chapel coffee. Because my left hand is going like that. And you got to make sure you don't fill that side too much because the coffee spills over. But it doesn't matter how low I fill it, I keep spilling it. See, and it gets worse if I start thinking about it. Focus. That's the best I can do. That's Jedi mind trick stuff right there. The real question is, how can I play golf with the shakes? It never actually affected my putting or anything. Sometimes when I have like a pressure shot though, like something that means something, when I set up over it, my hands start shaking like extra. So I have to do the Jedi mind trick thing. It's a good thing I'm good at that. Okay, so this is kind of a visual of a linked list. So we have a head pointer. So we have a node field that points to our first node, the head of the list. This node has a next node that points to the next node in the list. This guy has a next node that points to the next node in the list. This guy has a next node that points to the next node in the list. And this guy technically has a next node that points to a null. That's the end of the list. We're out of nodes at that point. That makes sense? So that's kind of a visual of what a linked list will ultimately be. When we first add something to our linked list, Haha. When we first add something to our linked list, it's going to look like that. So initially, our linked list has an initial state like this. So that's what our beginning linked list looks like. Go ahead.
Does it actually point to something that's null, or is it null?
Its value is null. Yeah, so
Point to something.
correct. Its value is null, but we can visually look at it as if it points to nothing. Because head holds a memory address. Whether it's pointing to something or not pointing to something, it holds a value. And the value it holds is the memory address it points to. So this guy points to nothing. So we can visually showing it as pointing. I mean, so I guess the issue here is your question, you asked, does it hold that value or does it point to it? I guess the real answer is yes. Because it's one and the same. A pointer is a primitive type variable that holds a memory address. So head holds a value. The value it holds is null, which means it points nowhere. It points to the null memory address, a memory address that does not exist. Okay, but because it's a pointer, the value it holds is also where it points. That make sense? Ish. It's 100% true. I promise. Okay. Well, how do you program with your shakes? It totally happens. I just start spazzing out and hit weird keys and stuff. It's terrible. I'm only 36. What's going to happen when I'm like 50? Yeah, I won't be able to carry briefcases or anything. I'll be swerving all the road driving to duct tape my arm to the side of my body. Just trust me, it's better this way. Okay, so the initial state after we first create a linked list is going to look like this. Okay, linked list has a single variable head that points nowhere. All right, so that's the visual version of this guy right here when we first create it. Okay, but now we want to be able to add things to our linked list. So the first thing we're going to add, let's say, I want to add the number 5, just for the sake of nothing. So I want to be able to come out here inside my driver, and I want to be able to say ll.add 5. And then I want to be able to say ll.display and have it show my new linked list with the 5 in it. So this is what I want to accomplish. I want to create a brand new linked list, which looks like this. This guy over here. Then I want to display it, which displays empty list because there's nothing in it. Then I want to add a 5 to it. Then I want to display it again. So let's deal with the adding 5 part to it. So I just took in an integer called 5. Now in order to add something to my linked list, I first need to package that 5 inside of a what? I need to make it into a node, correct? Because nodes are what are connected to each other on linked lists, not payloads. So we look at our node class here. We create a new node by passing it a payload, and it does the rest of the initialization magic. All right, so the very first thing I'm going to do in my code is I'm going to say node n is equal to new node payload. So whatever payload you passed in, I'll go ahead and create a node out of that guy. That make sense? And what does that ultimately do? It creates this for me. So now I have a node. Whose next node points to null, but whose payload is 5. Okay, so this is what exists right now. I have my linked list whose head points to nothing, and I have my new node that I just built who was initialized with its payload being 5 and next node equal to null, equal to nothing. And we see that programmatically right here. Payload is equal to whatever was passed in. Next node is equal to null. Make sense? All right, so that's what it looks like right now. Now I want to add this guy onto this linked list. Well, we're going to see the easy version of add first. So inside add, in our linked list, we're going to ask the question. If head is equal to null, meaning I'm currently dealing with the empty list. And is that our current state? Is head currently equal to null in our linked list? It is. So what are we going to do? We're going to make head point to our new node. Make sense? Head is equal to n. Perfect. So what did I just do? Connect. I did that. So now I have a linked list with one value in it. So I changed the value of head from being null to being the node that holds 5. But it's holding the memory address of that node. So it points to it. Does that make sense? Now we can update display. Because no longer is head equal to null. Now head is equal to something other than null. And we happen to know that the only thing that head could be equal to that's not null is a node. So if I'm in this else here, I must have a node to display. And that node might have something to display. Correct? All right, so I'm going to ask the node to display itself. So we're going to kind of write this, I always like to refer to this as sort of recursively. And you'll see what I mean here in a second. So we're going to dump, well, I'm not going to dump the toString. I'm actually going to rename the toString back to display. And you'll see why here in a second. So I changed this guy to be a void because I want a node to actually be able to print himself to the screen. Okay, so it's no longer going to return something. But we're going to still do this, the memory address followed by the arrow dealy thing. Okay, and what I'll do is I'll actually draw parentheses around it so it looks like a node, kind of a spaceshipy thingy. Because that's how you know it's cool, right? I'm going to say system.out.print. So when I just say print instead of println, what does it do? No character return at the end. So I'll print opening parenthesis concatenated with whatever super returns for toString, which will be weird memory address, concatenated with an arrow, concatenated with this guy's payload, concatenated with a closing parenthesis, then a real end parenthesis for the print statement, and a semicolon. Okay, but we're going to add a little more here. And actually, just for the sake of this argument, I'm not going to have it be an arrow in here because we're going to actually have arrows be our link. So I'm just going to put a space, colon, space in there. So we'll have memory address payload with a colon in between it. All right, so we will print out that value. Then we're going to ask a question because I'm a node. So right here, if we follow this, what did head do? He told the node he points to display himself. So this guy displayed himself. So I would have displayed my memory address followed by a colon followed by a 5 inside parentheses. Then it's his responsibility to display the next node because he's the only one that knows how to get there. Does that make sense? Head does not know about this guy. He has a means to an end. He knows that he can get to the node that comes after 5 by going through 5 and talking to his next node. So now we're going to have node ask the question, if this dot next node is not equal to null, that is, if I have a next node, what do I need to do? I need to ask him to display himself. So I'll say this dot next node dot display. Does that make sense? But notice that this guy, the display method, all he does is create a parenthesis followed by the memory address followed by a colon followed by the payload. So in order to actually show that link, I'm going to do a system.out.print. We'll put the space in there. So I'll quickly just print a little arrow. This is for visual only. All right, so if I do have a next node, I'll display a quick little arrow, And then I'll ask my next node to display himself. So that will come into this exact same method for my next node. That's why I say it's sort of recursively. We're calling the exact same method, but we're calling it for a different node. So a recursive call is when we call the same method multiple times. We call a method within itself. That's a recursive call. So I'm calling the display method within the display method, but I'm actually calling it for a different node. So that kind of makes it not recursive. So it's just sort of recursive. Okay? So we'll allow our nodes to take care of themselves. So all we're doing here is getting the ball rolling. We're saying, head has a next node. So it's not an empty list, so we'll ask our node to display himself. And then that node has the responsibility of displaying his next node, who has the responsibility of showing his next node, who has the responsibility of showing his next node, so on and so forth. That make sense? If we don't have a next node, we'll go ahead and be the guy who just kicks it down a line. So we'll be the final carriage return. That make sense? So in this case, we only have one node. So we ask the question inside of display for our linked list, is head equal to null? No. So we'll go to the node that is head, ask him to display himself. So what does he do? He does system.out.print, parenthesis, my memory address, colon, my payload. Then he asks the question, do I have a next node? No. So he'll do a println to kick it down a line for visual purposes. Okay? But if he did have a next node, he would ask his next node to display himself. And then his next node would ultimately put the carriage return in. So we're actually traversing this linked list, asking each node to display itself. So even though something fairly complex is going on here, our display method isn't overly complex. Because we're allowing each node to display themselves. Okay? So right now, with our linked list, we only know how to add very simple things. So we know with the add method that we can create a brand new node, we'll wrap our payload inside of a node object, and we only know how to add something to the empty list. That is, if head is equal to null, set head equal to n. That make sense? That's all we know how to do at this point. The second we have one node in our list, our code doesn't function yet. We're going to have to add that. But for right now, our driver should work. We create our linked list. We display it. Should say empty list. Then we'll add 5 to it. When we add 5, what happens? We create a node out of 5. We ask the question, is head currently equal to null? Yes, it was. The empty list had a head equal to null. So what do? We have head now equal to the node we just created. That make sense? Then we tell our linked list to display itself again. What does it do? Comes into his display method. We ask, is head equal to null? It's not. So since it's not equal to null, we won't print out empty list. Instead, what will we do? We'll say this dot head dot display. We'll tell the node to display itself, which then starts that chain reaction of all the other nodes displaying themselves. But now we can't add more than one node at this point. So when I hit play, I should see we have an empty list followed by a list with exactly one node in it. Here's its memory address. Here's its value. That make sense? Now let's talk about automatic garbage collection for a second. Oh, relax. Especially you, Amish. We don't need any pitchfork battles here. Automatic garbage collection. Okay, first of all, what is automatic garbage collection? Remind me. This is something I have not talked about in a while. This is early last semester. That doesn't mean you should not retain every bit of information that comes out of my mouth. It's all important. Flappy Birds, programming. This is golden stuff. You're paying for this. All right. You have to answer a question for me. What question did I ask? I remember now. I just looked at my slide. I had forgotten what question I asked. What is automatic? See, this is proof. If I can sit up here and do this, I'm vegetable lasagna. Go ahead. What's automatic garbage collection?
Something that cleans up the stuff that you're not using.
Okay, cleans up the stuff that you're not using, specifically memory. Okay, cleans up memory that you're not using. Okay, what does it mean for us to not be using memory?
Was to not be using.
Okay, I'll ask you, how do we use memory in our programming with Java? How do we claim memory in Java? We use our real estate agent, right? The new keyword. The new keyword goes out and gets us some memory. So we're laying claim to that memory. Now, automatic garbage collection is this, think of it like a big garbage truck. It's driving through memory, and his job is to clean up stuff that we're no longer using. How does it know whether or not we're still using that memory or not? I get to draw another picture. Well, I can do it in this picture, can't I? So in my add method for linked list, the very first thing I do is I create a variable called n. And then I use my new keyword to ask for some memory to hold a node. Correct? So n is a variable that points to my new node. Correct statement? Then what happens? Then, since my list is currently empty, let's see, extent to what my add method knows how to do, I make head also point to n. So I have two separate variables, each pointing to n. Does that make sense? Now, a memory address has something called a pointer count. So right now, this guy's pointer count is 2. Just an integer. Okay? His pointer count is 2. There are two things pointing to him. When this add method ends, the local variables within the add method die. So, was node defined inside of add? It was a local variable to the add method, correct? So when I hit the end of the add method, all those local variables die off, which means that at the end of that, n disappears. So does its link to my node. And this guy drops down to 1. Does that make sense? So this is all happening automatically behind the scenes. That variable disappeared. Therefore, it's no longer pointing to this memory location. Therefore, this memory location's pointer count just reduced by 1. So we have our little dump truck. What's a dump truck? That's a dump truck. Something's wrong with our professor.
Really, after a few years of
I guarantee I was a blast in preschool. Actually, I was a discipline problem in preschool, if you can believe that. It's really funny because when you're in preschool, or even kindergarten, I was a discipline problem for a while in school, I think. When you get in trouble, they make you sit underneath the chair. Like one of these chairs, you have to sit under it. Can you imagine? I one time fit under one of those chairs. Like easily. Sometimes there'd be 2 or 3 of us in there. Me and my gang. All right, so anyways, the dump truck comes along. I can tell you're all judging me. Okay, so dump truck comes along. His job is to clean up unused memory, to free it up so that somebody else could use it later on. Because remember, the new keyword is a real estate agent. She's going out looking for unused memory in order to claim it for new variables we're creating, right? Well, in order to do that, we need to have unclaimed memory, which means that memory that used to be claimed that's no longer claimed needs to now be marked as unclaimed. So the dump truck's going along. How does it know that this memory address is not safe to delete? The pointer count is not 0. When the pointer count becomes 0, so let's just say we decided to delete head for whatever reason. Now the pointer count becomes 0. Nothing is currently pointing to this guy. He exists. He's out there, but there is literally no way to get to him. Does that make sense? Specifically in Java. In an older language like C or C++, we could technically walk memory and hope for the best. Right? We can go on a, needle in the haystack search, if you will. Search through your 16 gigs of RAM, looking for the long lost node. Okay. So in any case, as soon as the pointer count drops to 0, the garbage truck knows that it can come and what's the name of that card game? Against humanity. It can make a strike against humanity. I just didn't want to forget the name of the card game, so I have to keep it flowing through there. Okay, so in any case, when the pointer count is 0, we know we can get rid of that node. Make sense? All right. So, since this guy now is 0, we can get rid of it, but that's not the case. Still has a pointer count of 1, so the dump truck's going to pass it right up because something still points to that guy. We can still get to that guy. So he's not unused memory. Make sense? How that works? Okay, and that's all happening behind the scenes for us. Now, what's interesting is this automatic garbage collection is a feature of our more modern languages. When we were in an older language like C++, it was our responsibility as the programmer to clean up after ourselves. So after the method ended and we got rid of n, we knew we didn't have to do anything special because there's still something pointed to it. But let's say at some point we remove this node. Assume I was able to remove that node. And it's just floating out here. And then my method's going to end, so the last piece of, the last node or last pointer to that guy is going to disappear. It is my responsibility as an old style programmer to delete this memory. Make it available. That make sense? All right, so that was because the garbage truck didn't exist. Good thing about the garbage truck is it makes it less, it takes away the responsibility of the programmer. Now, is that a good thing? For modern programmers, especially if you're learning programming today, it causes you to not appreciate memory because you're not forced to deal with memory. So as a Java programmer, I'm just showing you what's actually happening behind the scenes. You never actually have to do this. But as an older C or C++ programmer, it was your responsibility to delete memory that you were not using anymore. But a lot of programmers didn't do that. They either didn't understand memory or were just too lazy to clean up after themselves. Is that the end of the world? I got plenty of memory. No biggie. Well, what would eventually happen? Your system would eventually run out of memory, maybe after many, many, many months of writing software and doing different things because, especially if you were running other people's software that was also not cleaning up after themselves, over time your memory gets so, taken up by used space that was technically unused space that when you requested more memory, it would have nowhere to put it. You had 16 gigabytes of RAM that wasn't being used, but was being used, was being held hostage, if you will. Okay, that kind of makes sense? So, as a modern programmer, this isn't something we have to worry about, but we should appreciate what's happening behind the hood, or under the hood. So, up until recently, as an iPhone programmer, so if you're writing this code in Objective-C using Xcode, writing for Mac, automatic garbage collection is enabled. But if you were using the exact same tool, writing code for the iPhone, automatic garbage collection was disabled because it's an extra process running on the operating system and drains battery life. Hurts performance and drains battery life. And that's the last thing you want when you're running off a battery, right? So as an iPhone programmer until recently, we were responsible for cleaning up our own memory because it was more battery efficient on iPhone. An Android developer, because the core language is Java, they didn't have control over that. Java has automatic garbage collection, period. All right, so that's another reason why Android battery life in most cases is worse than iPhones. It has all these things working against it. None of which are actually Google's fault. It based it off of Linux, which had a great multitasking model, but was built for things that are plugged into the wall, not for mobile devices running off a battery. So you had 30 different applications in the background, the 17 of them that you accidentally clicked on, and then the 4 or 5 that you actually put in the background, and they're all still running, taking up battery life. That's why they had the apps to kill off other apps on Android. That's the reason why these existed, because they had a very, very, very good multitasking model, assuming it was a desktop computer plugged into the wall. And this is the whole reason why iPhone took a couple of years before it even introduced its fake multitasking. Even today, it's still fake multitasking. When something goes into the background on the iPhone, only part of it's still running. The developer is responsible for deciding which aspect of the operating system to hook into, if any. Otherwise, it's not taking up any processing power. It's in the background, but not really running in the background. It might as well not even be launched. But that's not a weakness of Android. It's because they adapted an older technology. Just is what it is. In fact, you might even say it was dumb luck by Apple. Apple's programming languages, Objective-C, has for years kept to some of the older styles. That is, requiring you to delete memory and that kind of stuff. It has not evolved as quickly as the modern languages on the PC, C# and Java. Well, Java is platform dependent, but you get what I'm saying. So because of its lack of evolution, the iPhone had an advantage right out of the gate because the programmer was responsible for doing a lot of things that hurt battery life on Android. Because the people who are writing software for Android are Java developers who are used to not having to clean up memory. The people who are writing software on iPhone were Objective-C developers who were used to having to clean up memory. So really it was dumb luck by Apple that they had a battery life advantage from day one. They made the good decision with not including multitasking, but before that even happened, this automatic garbage collection thing was maybe a dumb luck benefit of the idea of being powered off a battery. So don't give Apple too much credit. Sometimes you luck out, right? But they did make the right call with the multitasking, and they definitely made the right call with Flash. That was an interesting thing. How many of you are Android users? How many of you have been Android users for a while? Remember when you used to brag that you had Flash and Apple didn't? Remember that? Remember how the commercials used to brag about that? How's Flash running on your Android devices these days? When was the last time you looked at a Flash website on your Android device? Doesn't work. About 3 years ago, Android yanked Flash. Didn't really say much about that. Just they didn't have commercials and said, "By the way, we're wrong. We got rid of Flash." They just kind of stopped bragging about we have Flash and you don't, because the mobile version of Flash is garbage, kills battery life. You can actually see it on if you have a laptop. Go to like Yahoo with the Yahoo Games or something like that, and don't plug in your laptop and play some weird poker gamers. Just leave it open. Your battery life will just burn, even on a modern laptop. The mobile version of Flash, well, the desktop version of Flash is just very, very power hungry. Who cares if you're plugged into the wall, especially when Concordia is paying the power bill, right? Doesn't matter. But if you are on your cell phone and you want it to work all day long, Flash was a very poor choice. Hence the advent of HTML5. So another one for Apple, but who's counting, right? Score one for Android because Apple just stole their interface. So Android's keeping up, right? That's pretty much iOS 7 really incorporates a lot of Android's interface stuff, doesn't it? So I'll give one to Android for that one. Okay, so anyways, that's the deal with automatic garbage collection. We don't have to worry about it as Java programmers, but we should appreciate that it's there. Just like we should appreciate the little play button in Eclipse. What's actually happening behind the scenes. Okay, so at the end of add, right now we can only add something to the empty list. Well, what if we're not dealing with the empty list? That is, we're dealing with a list that has at least one node in it. Because that's all that head knows about, right? If we're not dealing with the empty list, all we know right here is that head points to a node. We don't know if there's no more nodes after that or if there's a million nodes after that. We just know that head points to one node. And only that node knows who comes next. And only that node knows who comes next, and so on and so forth. That makes sense? So if we are in charge of adding a node, so I'm in linked list right now, and linked list has been asked to add a node to the linked list. Very first thing we did is we wrapped that node up, or wrapped that payload up inside of a node. So we made our package ready to take over to the UPS store, right? Packaged it up, taped it, all that crap. Now we determine, hey, can we just locally add it? Is this the first element of the list? In this case, it's not. So we need to add this guy to the list when we don't have control to add it to the list. So we're going to have to teach our nodes how to add a node to the list. So we're going to go into node. We're going to add a new method to node. And let me actually go back to our code here. Nodes know how to display themselves right now. Nodes also know how to add a node. That's an ability we're giving them right now. So we're going to say public void add. This guy's going to take a node n as a parameter. And this node's job is to either set his next node equal to this node in the event that he does not have a next node, or ask his next node to add this node. That make sense? So if this dot next node is equal to null, great. Everything's solved. This dot next node is equal to n. I'm done. So if I don't have a next node, my job is to make my next node pointer point to this brand new node we're adding to the list. Make sense? That's the easy case. Otherwise, unfortunately, I already have a next node. So it's not my problem. I'm going to delegate the task of adding this node to my next node. So I'll say this dot next node dot add n. I'll just ask that guy to add them. Just passing the buck until finally we run into somebody that could add it as his next node. That make sense? Okay. So, an interesting thing to notice here with the linked list data structure. Notice that most of these methods we're writing look very simple, look very compact. But there's actually a lot going on in them because of this kind of fake recursive call. We're just passing the buck. Somebody's going to be able to get inside this first if statement. We're going to eventually run into some node that doesn't have a next node. And he'll be able to just set his next node to n and we'll be done. But until that happens, we're just going to keep passing it on to our next node. So there's a lot of complexity built into a very short chunk of code here. So that's something we should appreciate. So now, if we're inside the add method inside of linked list, if we can't just set head equal to that guy, what are we going to do? We're going to say this dot, well, that's fine. This dot head dot add n. So we'll ask the node that head points to go ahead and add n. And then he's going to go through that process of determining whether he can set his next node to it or if he has to pass it to his next node to get added. Make sense? So now we'll see if we just run it right now. Works the same way it worked before. But what I'll go ahead and do is I'll add some more methods there, or some more values to our list. So I added a 10, 11, and a 2. So now I should have a neat display of 5 linked to a 10, linked to an 11, linked to a 2. That makes sense? And how did we build that? Out of our simple little display method here. And what does this guy do? He says, well, if I have nothing in my list, print out an empty list. Otherwise, ask the node that is the head to display itself. And what does the node do? He says, if I don't have a next node, or if I do have a next node, well, first thing I do is I print out myself. I print out my memory address, followed by my payload, inside parentheses. So the very first thing that any node does to display himself is he prints out without a carriage return himself. Then he asks the question, if I do have a next node, I'm going to add a little arrow to the end of the line, and then I'm going to ask my next node to display himself. If I don't have a next node, I know I'm the end of the list. And if I'm the end of the list, what do? Just do a carriage return. Print in the empty string. Does that make sense? And that gets us to our nice output. Questions about any of that? All right, so for homework, this goes back to monkey see, monkey do. Write a linked list class and a node class. Well, basically create a linked list implementation that allows you to add nodes. Only add, and the linked list should be able to display itself. You can choose a different format for displaying if you'd like, but basically mimic what we just did in class to some level. Make sense? Don't forget to include the self-evaluation, so I know where you ran into problems. Some of you didn't do this on your last assignment. And if you go in and look at your grade, I probably gave you something that said, I'll let this slide this time, but don't forget to do this again, because in the little instructions, I tell you I'll give you a 0, but at some point you need to be trained, I guess. So in any case, I'll put the assignment up now. This will be due on Thursday. Questions, comments, concerns, bribes? Is that just a quarter? There's a nickel. Looks bent on the top. If it pulled it out of his ear. I mean, if it was like Italian money or something, we could maybe talk.
I have some euros.
Some of my grad students, they bring me Pakistan money and Indian money and rupees. I got
Swedish money.
I got rupees. Rupees.
Oh, cool.
Is that like enough to buy a candy bar?
Yeah.
That's some of my grad students, they'll bring me it's like a 500 rupee bill. And that he's like, this is something we would hand to hobos on the street. All right, I'll see everybody on Thursday. Remember, Bible study today, Tuesday. Free lunch, go to the cafeteria, tell them you're going to Bible study, take your tray across the hall to Lakeshore Room and have free God and grub.